In modern production environments, machines, sensors, and IoT devices generate terabytes of data every day. Industrial data often contains sensitive information, intellectual property, and even personal details. The recommended approach here would be to balance on scalability with control and reliability. Many production assets still use some old communication protocols, making it hard to connect them with modern IoT systems. Data delays or losses can occur, leading to delays in automation and monitoring. I'm Yuri, Head of Cloud Engineering at Lemberg Solutions, and in this video we'll explore some of the most common technical challenges in industrial data management, and I will share a few practical strategies that can help overcome them. Data volume and velocity. In modern production environments, machines, sensors, and IoT devices generate terabytes of data every day. The real challenge is not collecting it, but also managing its velocity and identifying what's truly valuable for decision-making. A workable solution here is edge data processing, filtering, and data aggregation close to where it's produced. This reduces bandwidth, improves real-time insights, and ensures that the relevant data is sent to the cloud or central system for deeper analysis. Security and compliance. Industrial data often contains sensitive information, intellectual property, and even personal details. Protecting information while complying with regulations like GDPR or sector-specific standards is required. Multi-layered security is common in cloud environments, but it's often not yet applied on the factory floor. A workable solution is to adopt secure device identities, encrypted communication, strict access control, define data retention policies early, and use automated compliance monitoring to enforce storage, access, and deletion rules consistently across all systems. Infrastructure scalability. Traditional industrial systems were not designed for the scale of today's IoT or AI-driven analytics. As data grows, legacy architecture quickly reaches performance limits. The recommended approach here would be to balance on scalability with control and reliability. You can move towards a hybrid or cloud-native architecture, use the cloud for elasticity, long-term storage, and large-scale analytics, while keeping edge or on-prem components for real-time operations. Latency and real-time control. In manufacturing, milliseconds usually matter. Processes involving PLCs, CNC machines, and robots require real-time instant messages. And that's something that cloud alone cannot guarantee due to latency. Use edge computing for control and time-critical decisions, deploy lightweight machine learning models locally, and synchronize summarized data with the cloud. This ensures fast local reactions while maintaining centralized data visibility. Legacy machine integration. Many production assets still use some old communication protocols, making it hard to connect them with modern IoT systems. How to deal with that? You can introduce protocol converters and IoT gateways that could translate data from protocols like RS-232, Modbus, or other to IP-based protocols. Add wireless sensors where possible and digital twins to virtualize legacy machines. It can allow engineers to analyze machine data without impacting live operations. Low-latency industrial networking. Many factories rely on a mix of wired and wireless systems built over the time. And because these networks differ in speed and reliability, data delays or losses can occur, leading to delays in automation and monitoring. What can you do with that? You can use layered network design, wired connections for time-critical controls, and modern wireless links for less urgent data. And also local gateways to buffer and align communication, ensuring stable, low-latency data flow across the factory. To modernize industrial data management, you don't need to replace everything. You need to connect, secure, and scale what already works. Combining edge processing, secure connectivity, and hybrid cloud infrastructure, you can turn raw industrial data into a reliable foundation for automation and continuous improvement.